Interstellar wasn't just a movie, it was a cosmic field trip that left us all Googling, what is a black hole? At 3 a.m., Christopher Nolan didn't just blur the lines between sci-fi and reality. He tore them apart like a spaceship entering a wormhole. Who knew a movie could make theoretical physics cool while also turning Matthew McConaughey's tears into an emotional meme? This film didn't just entertain, it sparked a nerdy obsession with space, inspiring scientists to rethink the universe, and the rest of us to question why we failed high school physics. Buckle up, because this is where sci-fi meets reality in the most mind-bending way possible. The science behind the spectacle. At the core of Interstellar's jaw-dropping scientific authenticity is Kip Thorne, a Nobel Prize-winning physicist who didn't just consult on the film, he built its scientific backbone. Thorne worked hand-in-hand with the filmmakers to ensure every detail was rooted in real physics, making the movie a spectacle grounded in truth. And let's be honest, who else could pull that off? Take Gargantua, the mesmerizing black hole that became the movie's centerpiece. Most sci-fi films might have settled for a generic swirling CGI donut, but Interstellar took it to a whole new level. Thorne used Einstein's general relativity equations to guide the visual effects team in creating a scientifically accurate depiction of a rotating black hole. The gravitational lensing effect, the way light bends around Gargantua, wasn't just for show. The team developed brand new CGI software for the task, pushing the boundaries of both science and cinema. Here's where it gets wild. Some frames of Gargantua took up to 100 hours to render. Let that sink in, one frame. The visual effects team generated over 800 terabytes of data for the film, roughly equal to the entire content of YouTube back in 2010. This wasn't just filmmaking. It was a full-scale scientific experiment in disguise. Even better, Interstellar didn't just win over moviegoers, it caught the attention of the scientific community. The depiction of Gargantua was so accurate that it led to published academic research. Now, scientists refer to Interstellar when discussing black holes. Imagine setting the bar so high for movie night that you end up redefining how we visualize the universe. That's the legacy of Interstellar, a film where every pixel was both art and science. From silver screen to scientific discovery, the realistic portrayal of Gargantua in Interstellar did more than just win Christopher Nolan an Oscar nomination. It reshaped how we understand black holes. Before the film, visualizing the behavior of light near a black hole was primarily confined to chalkboards and equations. But Interstellar's stunning visual effects, created with the help of physicist Kip Thorne, gave scientists an unprecedented look at gravitational lensing, the bending of light caused by a massive object. For the first time, researchers could simulate and analyze these phenomena in a way that felt tangible, all thanks to a blockbuster movie. Take the accretion disk, for instance, the glowing ring of gas and dust spiraling into a black hole. Before Interstellar, most scientists assumed these disks were flat, pancake-like structures. But the movie's depiction, with its mesmerizing warps and distortions caused by extreme gravity, changed the game. Scientists suddenly saw a more dynamic, warped version of these disks, inspiring new models and theories. It was as if science fiction looked at astrophysics and said, "Hey, let me show you something cool." And then there's the wormhole, a concept we've all heard about, but rarely understand. In Interstellar, the wormhole isn't just a magical portal. It's a carefully constructed visualization of how one might actually work, bending space-time in a way that respects Einstein's theories. While wormholes remain theoretical, the film's portrayal brought them to life, sparking curiosity among scientists and audiences alike. Unlike other movies that wave their hands at science, Interstellar reminded us that concepts like time travel and bending space-time don't just require a flashy DeLorean, they require real math. Kip Thorne's meticulous guidance ensured the film remained rooted in physics, even when it ventured into the fantastical. In doing so, Interstellar didn't just entertain, it educated, leaving a lasting impact on both Hollywood and science. Who knew a trip through a wormhole could bend our understanding of the universe itself? Inspiring the next generation of explorers. If Interstellar taught us anything, it's that you don't need a spacesuit to fall in love with space exploration. The film didn't just dazzle scientists, it ignited a fire in everyday people, students, and budding engineers. NASA even praised Interstellar for its scientific accuracy, noting how many of its visuals align with real-world physics and space missions. It's not every day a Hollywood blockbuster earns applause from rocket scientists. Even Elon Musk, the visionary behind SpaceX, has mentioned how films like Interstellar keep the dream of space colonization alive, pushing humanity closer to becoming an interplanetary species. But the movie's reach didn't end with moviegoers, it leaped into classrooms around the globe. Teachers now use clips from Interstellar to break down Einstein's theory of relativity. Take time dilation, for example. The movie's depiction of time moving slower near Gargantua, a supermassive black hole, made this notoriously complex concept relatable. Students couldn't believe that every hour the crew spent on Miller's planet near Gargantua equated to 7 Earth years. Talk about the ultimate excuse for a late homework submission. Even more fascinating, Interstellar has inspired a new wave of young scientists and innovators, many now pursuing careers in astrophysics, aerospace engineering, and visual effects. Credit the film for sparking their passion. Suddenly, math and physics went from being the boring subjects to the coolest tools in the universe. The movie also showcased how creative problem-solving, like figuring out how to bend space-time, could lead to groundbreaking discoveries. In a world where space exploration can feel distant and theoretical, Interstellar brought the stars closer to home. It didn't just entertain, it planted seeds of curiosity and ambition in millions of minds. Who knows? The next generation of explorers, engineers, and dreamers might just look back on Interstellar as the movie that started it all. A legacy of accuracy and imagination. What truly sets Interstellar apart is its unparalleled commitment to realism while keeping the flames of imagination alive. Where most space films cut scientific corners for the sake of drama, Interstellar went all in on accuracy, transforming it into both a cinematic masterpiece and a physics lesson. That's where the magic lies. It turned gravitational time dilation, wormholes, and black holes from abstract theories into visually stunning, digestible concepts. Kip Thorne, the Nobel Prize-winning physicist who consulted on the film, ensured every frame respected the laws of physics. This isn't just sci-fi. It's science brilliantly woven into fiction. Take gravitational time dilation. Before Interstellar, most people had no idea time could move slower near a massive object like a black hole. The movie's depiction of Miller's planet, a world so close to Gargantua that 1 hour equals 7 Earth years, made this complex phenomenon accessible and unforgettable. And let's not forget the wormhole. Unlike the glowing portals we're used to in movies, Interstellar's wormhole was a scientifically accurate, 3D visualization of how space-time could bend and fold, allowing instant travel between distant points in the universe. Even the visual effects were a groundbreaking achievement. The rendering of Gargantua's accretion disk was so precise that it generated real scientific insights. Researchers used the simulations created for the movie to study light distortions around black holes, a process that would have taken years of theoretical modeling. More than a decade later, both filmmakers and scientists still revisit Interstellar to marvel at its accuracy and innovation. But the movie's legacy goes beyond the lab. It's become a cultural touchstone, inspiring future astrophysicists, engineers, and dreamers. From classrooms to space agencies like NASA, Interstellar is used as a teaching tool and a source of inspiration. And for the rest of us, it's a reminder of what's possible when creativity and science collide. As humanity continues its journey into the cosmos, one thing is certain. When we look back at our progress, we'll always tip our hats to Interstellar and say, this is where the dream began. And that's the cosmic ride for today. Folks, if Interstellar blew your mind as much as it did ours, hit that like button, smash subscribe, and join us for more jaw-dropping journeys through science, film, and everything in between. Stay curious, stay inspired, and we'll see you on the next adventure.